Good day everyone, and especially to you ma'am, good day. So my name is Marshall Maquiling, and in this video we will going to explore and discuss some important concepts related to the heat flow of Earth's atmosphere. So first we're going to discuss is all about warming the Earth and the atmosphere. So without further ado, simulan na natin to. So, but before that, here are our objectives. Evaluate the heat flow of Earth's atmosphere and discuss how the atmosphere absorbs and emits heat. And the last one is solve problems atmospheric thermodynamics. So in warming the Earth and the atmosphere, we will cover these following topics. First, we have the temperature. That will be our first topic. And the second one, we have the rising air cools and sinking air ones. The third one is the absorption, emission, and equilibrium. And the last one, we have the solar energy. So the first we are going to discuss in this video is the temperature and heat transfer. So let's start with the temperature. So when we say temperature, it is a measure of how hot or cold something is. So it tells us how much energy the atoms and the molecules have, or in other words, when we talk about temperature, this measures kung gaano kainit or kalamig ang isang bagay. So, a higher temperature daw means faster movement of atoms. So, and this energy of motion is called the kinetic energy. We also have this term called absolute zero, which is the lowest temperature possible or at negative 200 degrees Celsius. So, at this point, kaunti lamang ang energy ng atoms na nabibigay ni absolute zero. So next, let's talk about the heat. So heat is the energy that is transferred sa pagitan ng mga bagay dahil sa pag-iiba ng ating temperatura. So once heat is transferred or mailipat ang init, ito ay nagiging internal energy stored in the object. So in our atmosphere, heat is transferred through conduction, convection, and radiation. So now let's talk about the different types or the different temperatures scales. So first we have the Kelvin scale, introduced by Lord Kelvin, a famous British scientist, on 1824 to 1907. So this scale has no negative numbers, hence mas convenient or dali lang siya gamiton for scientific calculation. So on the other hand, we have a Fahrenheit scale which is developed in early 70s by a physicist G. Daniel Fahrenheit, where gi-assign niya ang number 32 to temperature na mo-freeze ang water ug ang number 212 na temperature para mo-boil ang water, which is gi-develop ni G. Daniel Fahrenheit. So lastly, we have Celsius scale. So Celsius scale introduced in the late 18th century. So kani siya na scale, the number 0 is assigned as temperature at which water freezes, and the number 100 as temperature where water boils. So lahi sa kung unsa ang sa Fahrenheit. So let's have the formula for converting degrees Celsius to Kelvin, degrees Fahrenheit to Celsius, and degrees Celsius to Fahrenheit. So here our formula. Here is the formula for converting degrees Fahrenheit to degrees Celsius. So degrees Celsius is equal to 5 over 9 multiplied by degrees Fahrenheit minus 32. Next, we have the formula in converting degrees Celsius to degrees Fahrenheit. So, the formula for that is degrees Celsius is equal to 9 over 5 multiplied by degrees Celsius plus 32. And the last formula in converting degrees Celsius to Kelvin. The formula for that is Kelvin is equal to the degrees Celsius plus 273. So let's have our examples. So we have in our first example, we have here a formula for converting degrees Fahrenheit to degrees Celsius. So our formula here is degrees Celsius is equal to 5 over 9 multiplied by degrees Fahrenheit minus or subtract by 32. So since our given here is degrees Fahrenheit is equal to 12, since our degrees Fahrenheit is equal to 12, the next process or the next step that we're going to do is to substitute the formula. So we have here our degrees Celsius is equal to 5 over 9. Since the value of degrees Fahrenheit is 212, to change the degrees Fahrenheit into 212 minus 32. So the next step that we're going to do is to subtract the 212 subtract by 32. So 212 minus 32, we get the answer 180. So to find the further answer is we're going to multiply 180 multiplied by 5 and divided by 9. So first we're going to multiply 180 multiplied by 5 and we get the answer 900 over 9. So the final step in converting the substituting the formula is 900 divided by 9, so we get the answer 100. So the answer we get from converting degrees Fahrenheit to degrees Celsius is 100. So let's move to our second example for a formula for converting degrees Celsius to degrees Fahrenheit. So our formula here in converting degrees Celsius to degrees Fahrenheit is degrees Fahrenheit, since Fahrenheit ang ato gihanap. So degrees Fahrenheit is equal to 9 over 5 multiplied by degrees Celsius plus 32. So our given here for the answer for the given of degrees Celsius is equal to 100. Why 100? It is why that we're going to prove if sakto ba ang atong answer na or sakto ba ang ato pag-substitute to find the answer degrees Fahrenheit. Since ganiha ang atong example is ang atong gihanap is degrees Celsius, now we're going to solve a formula in converting degrees Celsius to degrees Fahrenheit. So the next we're going to do is to substitute the formula. So degrees Fahrenheit is equal to 9 over 5 multiplied by 100. Since the degrees Celsius is 100, we'll change the degrees Celsius to 100 plus 32. The next step we are going to do is to multiply 100 by 9 divided by 5. So first we're going to do is to multiply first. So 100 multiplied by 9 is equal to 900 over 5 plus 32. So the next step we're going to do is to divide 900 by 5 and we get the answer 100 plus 32. And 180 plus 32 and we get the answer 212. So 212 is our degrees Fahrenheit and our answer from the first example is our degree Celsius is 100. So we prove that in our formula in converting degrees Fahrenheit to degrees Celsius is correct, and converting degrees Celsius to degrees Fahrenheit is correct. We proved earlier that our answer 212 given from degrees Fahrenheit is 212, and we proved it from the second example. Okay, so we move from the last example, and it's a formula for converting degrees Celsius to Kelvin. So our formula for that is Kelvin is equal to degrees Celsius plus 273. So since our given example earlier is degrees Celsius is equal to 100, so the next step is we're going to do is to substitute the formula. So Kelvin is equal to degrees Celsius, since degrees Celsius as a given problem or given problem is equal to 100. Since degrees Celsius is equal to 100, change a degree Celsius into 100, so we put here 100 plus 273. So the final answer is Kelvin is equal to 273. So that's all in converting degrees Celsius to Fahrenheit, degrees Fahrenheit to Celsius, and degrees Celsius to Kelvin. So next we're going to discuss is the latent heat or hidden warmth or nakatagong init. So in other words, this is an energy na kinakailangan upang baguhin ang isang substance from one state to another. For example, tulad ng tubig na mula sa pagiging likido or liquid patungong singaw, or also known as evaporation. So this is an energy stored in the water vapor and released when it condenses back to liquid, or kapag ito ay inilabas bilang liquid, or simply what we call as the latent heat of condensation. So just like this example from this figure, which shows us to how heat energy is absorbed and released. So mag-start siya gikan sa ice, mamelt siya and will then evaporation through sublimation process and will then form a vapor. So from that vapor, mo-condense siya and will turn into a liquid, become to freeze, and will go back to become an ice through the process of deposition. So another figure, we have the huge cloud in the picture as the example, where sa sulod-ani na cloud is my amount of heat energy na mo store, which will become or develop into thunderstorm. So from time to time, magkabugat siya and it will then produce a water vapor, and that will result to a raindrops or mag-ulan na siya. So at this point, let us discuss as how heat is transferred. So first we have conduction. This is when the heat transfers from molecule to molecule within a substance. So just like the figure shows na as the needle or dagom in Bisaya is hidden up within a candle through one end, is dali da mo transfer ang iya kainit to the other end, since it says na metals are strong conductors of heat, and on the other hand, low conductors of heat is ang mga woods. So conversely, air is an extremely poor conductor of heat, which is why most insulating materials have a large number of air spaces trapped within them. So next we have convection. So when we say convection, it occurs when heat moves or move siya sa pamamagitan ng mass movement of liquid and air. So the rising air bubbles are called thermals. So when we say convection, mahitabo siya if mutaas ang pressure or mutaas ang hot air, allowing colder air or bugnaw para siya mo init. So for example, if you put a cold water above a firing gasol, due to the pressure or hot air is muinit siya and mo-boil, which will cause the water to rise. Mauna siya ang pasabot when we say convection. So in conclusion, understanding this concept helped us how to analyze on how this atmosphere works in terms of heat transfer and energy movement. So thank you for listening, and that concludes my report. So let me give the floor to my group mates.
Raising air cools and sinking air warms. So how raising air cools and sinking air warms happens. So first is the raising air cools. So as air raises, it enters regions of lower atmospheric pressure. With less pressure pushing down on it, the air expands. This expansion requires energy, and the air pulls that energy from its internal temperature, causing it to cold. So pasabot kung kung ang air kuno is mo raise, mo-cool siya because maka-enter siya ng regions of lower atmospheric pressure. And then tungod ani mag-expand dra ang air. Then mo dayon ang result is mo-cool dayon siya. Tungod sa expansion. And then diri pod sa sinking air warms, conversely, as air sinks, it encounters higher atmospheric pressure. The increased pressure compresses the air, forcing the air molecules to closer together. This compression generates heat, causing the air to warm. So diri pod sa sinking air kung mo lubog ang kung paubos ang air, mo warm siya because maka-encounter pod siya ng higher atmospheric pressure. Then, sa increase ng pressure, mo-compress ang air. Mo dayon to nga, ma-force ang molecules closer together, and then, ang compression ato is mag-generates ng heat. Mo dayon na nga makakos ng warm. Then, example, think of it like this. Imagine you're pumping up a bicycle tire. As you push the air into the tire, it gets warmer because you're compressing it. So, di ba kung flat ang bike din imong bumbahan. So, di ba? Kaya mo compress man ang kuan sa ligid ang air, so mo na siya nga mag-cause ng warm. Then, now imagine you let the air out of the tire. As the air expands, it cools down. So, di ba pag imong buhian ang tanggalon nimo ang katong murag pen ng hangin sa pagbumba ng bike, ana. Di ba pag gawas ng air is cool na siya, kanang bugnaw na kay nag-expand like that. So, mo nang example para mas masabtan. So, this is called adiabatic because the heat exchange is slowly due to changes in pressure, not the transfer of heat from or to another object. So, ang tawag ani di nila is adiabatic. Kay tungod, nag-exchange naman sila tungod sa pressure, dili transfer ng ilang mga energy to one another or heat like that. Then, ang example ani is the cloud formation, thunderstorm, mountain ranges. So, kanina mga example is sa air out, sa raising air cools. So, ang first day is ang cloud formation. Raising air cools, and it cools enough, the water vapor in the air condenses into cloud. So, pag Pag mo-raise ko na ang kuan, makakuan kapon siya ng cloud formation because kung mo-cools enough na siya, magka-water vapor man, then mag-condense, muna dahil na mahimo ng cloud. And then sa thunderstorms, racing air thunderstorms and condenses releasing latent heat which fuels the storm. So, para ra gihapon ni racing air gihapon, makakos dayon ng racing air mo dayon na sa thunderstorm, mo cool, mo condense, mo dayon na naman po ang thunderstorm. And then sa mountain ranges, air force to race over mountain schools, often leading to precipitation on the windward side of the range. So, kumatinga mo sa kilid ra ang iyang naiulan because ang dire masyado naman good siya ang sa kilid kaning mga kuan na part dito na part sa dry because murag masyado na lang siya. So dire ma-air force gihapon race over mag-cools and then lead ng ulan madaday na ay atungod sa air racing.
Good day everyone, I am the next one to discuss to you about the absorption, emission, and the equilibrium. So before I further discuss my topic, let me first discuss the meaning of the absorption, emission, and the equilibrium. So absorption, it refers to the process of a substance absorbing energy typically from electromagnetic radiation such as light. Then the emission, it refers to the release of energy, often in the form of electromagnetic radiation by a substance. Then lastly, the equilibrium. It occurs when the rates or absorption and emission of energy by a substance are balanced, resulting in no net change in energy. The next one is, why doesn't everything get progressively colder? It is because all object not only radiates energy, but they also absorb it as well. If an object radiates more energy than it absorbs, it becomes colder. If it absorbs more energy than it emits, it becomes warmer. So, example diri kay, on a sunny day, the Earth's surface warm by absorbing more energy from the sun and the atmosphere that it radiates, whereas at night, the Earth cools by radiating more energy than it absorbs from its surrounding. So when an object emits and absorbs energy at equals rate, its temperature remains constant. So di ba kabantay mo kanang magbutang mo gani og isa ka butang sa lalim na suga, like for example motor, iyo mapasagdan sa like di niso mabantayan na napasughanan niso. So ato motor, it absorb heat coming from the sun. It absorb more energy na gikan sa suga. Then kapag maduyman na gani siya, di ba pag maduyman na, di ba mutignaw siya, it is because it emits ato heat na iya na absorb na gikan sa suga, mawaya siya or ma-emit siya, it is because laong diri kay it cools down by radiating more energy than it absorbs from its surrounding. Okay, so the next one is, when the rate of absorption of solar radiation equals the rate of emission of infrared Earth radiation, a state of radiative equilibrium is achieved. The average temperature at which this occurs is called the radiative equilibrium temperature. So, radiative equilibrium temperature is if the Earth absorbs solar energy and emits infrared radiation, it will reach a balance. It calls the radiative equilibrium. When the energy absorbed equals the energy emitted, it is known as the radiative equilibrium temperature. Okay, so the next one is the selective absorber and the atmospheric greenhouse effect. So which is the blackbody radiation, the selective absorber, and the atmospheric greenhouse effect. Okay, so the first one is the blackbody radiation. So the blackbody radiation is any object that is perfect absorber, that is absorb all the radiation that strikes it, and a perfect emitter. So it emits the maximum radiation possible at its given temperature. So it doesn't mean na black body ang iya dapat ang iya color is black. It is just because it simply emit and absorb all possible radiation. So the second one is the selective absorber. So the selective absorber is that objects that selectively absorb and emit radiation such as gases in our atmosphere. So ang selective absorbers, from the word itself selective, ang iya tag-absorb tapos tag-emit na radiation is selective da. Last is the atmospheric greenhouse effect. The absorption characteristic of water vapor, CO2 and other gases such as methane and nitrous oxide were at one time thought to be similar to the glass of Flores greenhouse. So ang glass of Flores greenhouse is building siya na made of glass wall then glass roof. Then ang iya clear glass, it allows the sunlight na musuyod kan dito sa greenhouse, then it trap the heat inside. Then this is how the greenhouse keep plants warm even in night. So the greenhouse effect warms the earth in the same way in the greenhouse. But unlike sa ato fluorescent greenhouse na surrounded siya of glass, the greenhouse effect, which is the earth, it is surrounded by a jacket of gases called the atmosphere. So in the daytime, the sunshine gets through the atmosphere, warming the Earth's surface. So after the sundown, it cools down the Earth's surface. This releases the heat back to the air. But some of the heat trapped by the gases in the atmosphere. These heat trapping gases are called the greenhouse gases, which is the carbon dioxide, water vapor, and the methane. So, the Earth needs a balance of greenhouse gases to maintain just right temperature for living things. Studies have shown that the warm air inside the greenhouse is probably caused more by the air's inability to circulate and mix with the cooler outside air, rather than by the entrapment of infrared energy. Because of these findings, some scientists insist that greenhouse effect should be called the atmosphere effect. We will use the term atmospheric greenhouse effect when describing the role that water vapor and CO2 play in keeping the Earth's main surface temperature higher. In summary, the atmospheric greenhouse effect occurs because water vapor, CO2, and other trace gases are selective absorbers. They allow most of the sun radiation to reach the surface, but they absorb a good portion of the Earth's outgoing infrared radiation, preventing it from escaping into space. It is the atmospheric greenhouse effect. Then that keeps the temperature of our planet at a level where life can survive. The greenhouse effect is not just a good thing. It is essential to the life on Earth. Enhancement of the greenhouse effect. So first is the global warming and the second one is the positive and negative feedback. So first is global warming. So many scientists believe that the main cause of this global warming is the greenhouse gas CO2. So diba I discussed earlier the atmospheric greenhouse effect. I discussed that the greenhouse gases should maintain balance so that our earth just have just right temperature for the living things. So because of the burning of fossil fuel and the deforestation, it will release more carbon dioxide or the greenhouse gas CO2 into our atmosphere, and this will cause that our atmosphere will trap more and more heat, leading to a warmer Earth. The last one is the positive and negative feedback. A feedback is a process whereby an initial change in a process will tend to either reinforce the process, which is the positive feedback, or weaken the process, which is the negative feedback. And the last part is the warming Earth from below. So I will discuss this through the last slide, which has an illustration. The illustration shows that the air lower atmosphere is heated from below. Sunlight warms the ground, and the air above is warmed by the conduction, convection, and radiation. Further warming occurs during condensation as latent heat is given up to the air inside the cloud. So, makita nito dito ang radiation, conduction, and convection. So, when we talk about radiation, radiation refers to the process by which heat is transferred between things without direct physical touch. Then the conduction is a procedure where heat is transferred between objects through physical contact. Then last is convection, is the type of heat transmission where there is an energy transformed within fluid. Okay, so that's all for my topic. By the way, I am Maya, I am JOSOL, and my co-member will discuss her topic also.
Good day everyone, I am Tricia Gonzalez Avila and my topic is all about incoming solar energy. Ang incoming solar energy, also known as solar radiation, is energy na essential sa ato life on Earth. Kay like for example sa photosynthesis, di ba ang photosynthesis manginahanglan ng sunlight to convert carbon dioxide and water into glucose and oxygen. Sa ina process, it can provide foundation of food chain o provide sa bini ng energy that sustain all life on Earth. Next is how the Earth stays warm. Tungod diyan sa sunlight na yagahatag ng heat sa Earth, which warms up the ground and air by conduction, convection, and radiation. So, conduction. Ang conduction, ang pag-transfer ng heat energy between objects or substance that has different temperature. Like for example, yaghawid ka ng cup of coffee. Ang init gikan sa coffee mo travel sa cup and into your hand that makes your hand warmer. Yan ang conduction, pag-transfer ng heat energy. Next is ang convection. Ang convection, ang movement of heat through fluids because of different in temperature. The warmer, less denser fluids rise while the cooler, denser fluids sinks. Like for example, mag-init kita ng tubig. Di ba pag mag-init kita ng tubig, makakita kita ng bubbles. Yan ang warmer water na raise sa surface, and as the warm water reaches the surface, it cools down and became denser. So ang cooler, denser water sinks back down to the bottom of the pot. So in this cycle of raising warm water and sinking cooled water continues, makakreate ini ng circular movement called convection current. Next is ang radiation. Ang radiation is ang pag-transfer ng heat through electromagnetic waves which can travel through space without needing a medium like air or water. For example, ang Earth o ang Sun, di ba ang Sun makahatag ng heat sa Earth even though it has free space, tungod diyan sa radiation. Another example is ang microwave oven. Di ba ang microwave oven use electromagnetic waves to heat food? These waves are form of radiation. Next is how the Earth's annual energy balance. So imagine the Earth has a giant bank account for energy. Every year, ang Earth makareceive ng huge amount of energy from the sun like deposit. This energy warms up the Earth's surface, air, and oceans. But the Earth also lost energy back into space like withdrawal. So, if ang Earth makareceive ng more energy than it lost, it will warm up. Pero if ang Earth lost more energy than it receives, it will cool down. This balance is crucial for maintaining a stable climate on Earth. So, in ang example, sa 100 units of sunlight reaches the top of Earth's atmosphere, ang 30 units ma-reflect back into space by clouds, ice, and the Earth's surface. And ang 51 units ma-reach sa Earth's surface which warms the ground and the ocean. This means that about 70 of sunlight that reaches Earth gets absorbed and warm up. This is how the Earth gets energy to support life. And that's all.
A good day everyone. Especially to our instructor, Ma'am Charmy Japra. So first of all, I would like to introduce myself. I am Jonas Rivera, one of the reporters in Group 2. So my assigned topic is the season in the Northern Hemisphere and the season in the Southern Hemisphere. The season in the Northern Hemisphere, through the years, a different part of Earth receives the sun's most direct rays. So when the North Pole tilts toward the sun, it's summer in the Northern Hemisphere, and when the South Pole tilts toward the sun, it's winter in the Northern Hemisphere. So, have you ever wondered, no, nangasama kasi natin kita ng seasons, no, different kind of seasons. So tungod yun siya sa motion and movement, no, na nato Earth na samtang naga-rotate siya around the sun. Naga-rotate isab siya in the axis, pagkatawag na imaginary line. So samtang maga-rotate siya sa imaginary line, which is the axis mo, so equivalent siya ng 1 day, so 24 hours. Then samtang maga-rotate siya around the sun, equivalent siya ng 365 days. So through the year, maka-experience kita ng 4 kinds of seasons, so which is the summer, winter, autumn, and spring. So when the North Pole tilts toward the sun, so mo tilts o mo takilid and ato earth sa sun in 23.5 degree. So pag makatakilid siya, which is most directly an North Pole, pag maka-tilt siya sa sun, so amin siya na mag-summer sa northern hemisphere, which is the northern hemisphere and the southern hemisphere. So, and when the South Pole tilts toward the sun, so on pag South Pole na pod and mo tilt sa sun, so it's a winter in the northern hemisphere. Ingana kibalian a system nan season, no? So next is the calendar seasons. So isa calendar ato makuanan, in the northern hemisphere, spring begins on the spring equinox around March 20. So ang spring magsugod siya around March 20. Summer begins on the summer solstice around June 21. So an autumn's season begins on the autumn equinox around September 22, and winter on the winter solstice around December 21. So ngayon magsugod kibali. So next is season in the northern hemisphere. So season na sabi sa southern hemisphere pa. So in the southern hemisphere, the season are reverse. So yakabaliktad siya ato mapansin na kung tukay na sa northern hemisphere, kung summer ngadto, so equivalent siya or reverse siya, or sa southern hemisphere is winter. So season in the southern hemisphere, in the southern hemisphere, the season are reverse. Spring begins in September, summer in December. So magsugod ang spring sa southern hemisphere is September, which is the summer sa northern is March 20 magsugod. So siya nan lahi aniya month nan iya season sa southern silang pa di. So spring begins in September, summer in December, fall in March, and winter in June. The consistency of a meteorological season allows meteorologists make the complex statistical calculation necessary to make a prediction and compare seasons to one another. So ingana ang system isab sa southern hemisphere. Next is the local seasonal variation. So the local seasonal variation refers to the change in weather pattern and environmental condition that occurs within a specific region due to the Earth tilts and its orbit around the sun. This variation influences the growth cycle of plant and animals, creating distinct seasons within the particular area. So a local variation is yon pagka-outro, no? refer siya sa pagka-outro ng mga panahon mo o environmental condition. So depende siya or sa pag-tilts ng sun ng earth nga to sa sun. So gilang nga di so the earth tilts cause different parts of the planet to receive a varying amount of sunlight through the year. This result in change in temperature and weather patterns, leading to the 4 distinct seasons: spring, summer, autumn, and winter. So yung nga na. So ani naman po nga di. So what is the impact, no, on human activities? Unsay impact kibali ang seasonal variation sa human activities? So may mga benefits na to, no, about this 4 seasons. Pero nga di sa ato sa Pilipinas, kung wala ko masayo, we have 2 seasons lang, summer o winter da. So summer, makasinati kita in month of December to March, ingana. So kay as a farmers gani, so, experience na ako, no, sa pagtanom ng palay or humay. So magsugod ang pagtanom, no, sa month of magsidling kibali, month of February, March, April, May na dahil and harvest time ingana. So the seasonal variation have a profound impact of human activities. Farmers rely on seasonal patterns to determine the best time to plant and harvest crops. So ingana kibalan farmers para kibali sila makatanom, kung hain kibali sila mak-harvest ng sakto. So example, magtanom ka ng humay or magtanom ka ng kalibre sa ating ulan, so dili siya capable na makaharvest ka ng damo-damo, although may mga makuha nimo, ma-harvest nimo, pero dili siya damo, dili siya good harvest kay tungod sa ating ulan malata ani mga unod. So gana, so kung magtanom ka, so around yon yaon sa month na summer. So tourism is also influenced by seasonal weather. So ang mga turista, seasonal weather condition with people planning vacation based on the climate during different seasons. So ingana yun, magadepende sa seasons ang mga turista. Additionally, seasonal variation affect energy consumption, clothing choice, and outdoor recreational activities. So damo nato ma-benepisyo sa seasonal na mga phenotypes or yaon panhitabo na nato matagtuig na mga seasons. So aniban sa lain na area, no, labi na sa Amerika, so makasinati sila ng yon winter ngadto, so nag-snow. So lahi isab an ato nga di sa Pilipinas, so wara kita makasinati na mag-snow ingana. So lahi-lahi an sistema or yaon season na yaon sa ato. So that would be all, and thank you for listening.